Numerical analysis with NumPy for market data. Learn how to use NumPy to analyze real-world market research and customer analytics datasets. We focus on basic and advanced numerical techniques to uncover business insights. You will analyze customer satisfaction, survey scores, and campaign performance using Python. These skills help companies make data-driven decisions, improve products, and understand market trends. By the end, you will summarize, aggregate, and visualize customer data to answer real business questions. Running the cell now. We import pandas to handle data frames for market research analysis. NumPy is imported to perform powerful numerical calculations and aggregations. OpenML is used to load real public market research datasets. We import warnings to manage warning messages. Warning messages are suppressed for clarity in notebook outputs. Running the cell now. Understanding market data and surveys. Market research data can include customer responses, satisfaction scores, or sales information. Datasets often have columns for demographic data, survey scores, and purchase behavior. Poor data handling may include misclassifying survey scales, missing values, or incorrect aggregations. Beginners often forget to validate data types or miss handling negative responses correctly. Running the cell now. We access a real customer satisfaction dataset from OpenML. We fetch the dataset by its ID. The data is loaded as a pandas data frame for easy numerical analysis. We print the number of rows and columns in this dataset. We preview the first 3 customer records to understand available fields. Running the cell now. This output shows the customer satisfaction dataset with 7,043 rows and 20 columns, reflecting a sizable sample with rich demographic and service-related features. Notice key columns like churn, monthly charges, and contract, which are crucial for analyzing customer retention and satisfaction trends. This initial view confirms the data's structure and helps us understand the variables we'll work with, emphasizing the importance of validating dataset shape and content before deeper analysis. We want to understand how long, on average, customers stay with the company. We calculate the mean of the tenure column using pandas. The result shows the average number of months customers remain subscribed. Running the cell now. This output shows the average customer tenure calculated from the dataset, which is about 32.37 months. Notice that the code summarizes a key metric, customer tenure, by correctly aggregating a numeric column, reinforcing the importance of validating data types before analysis. This step helps beginners understand how to extract meaningful averages from market data, ensuring accurate insights into customer behavior. Practice. Try calculating the median tenure, which gives a better sense of typical customer duration. Measuring churn is vital for customer retention strategies. We check whether churn column equals yes and calculate its mean as a proportion. The output tells us what percentage of customers left the service. Running the cell now. This output shows that about 26.54% of customers in the dataset have churned, based on the churn column containing yes or no responses. The code's intent is to correctly calculate the proportion of churners by treating the churn column as categorical data and using a Boolean condition, which is key for accurate market data analysis and avoiding misclassification. Noticing the percentage helps understand overall customer retention and highlights the importance of validating response categories before analysis. If you are interested in business storytelling, search customer churn analysis on YouTube for walkthroughs. Understanding gender distribution can inform marketing segmentation. NumPy's unique function counts how many male and female customers there are. We iterate over the unique values and their counts. The business can use this to see if their customer base is skewed by gender. Running the cell now. This output shows the count of male and female customers in the dataset, highlighting the gender distribution. Notice the close numbers, 3,555 males and 3,488 females, indicating a balanced sample, which is important for unbiased market analysis. This step ensures correct classification and counting of categorical data, a key part of validating survey demographics. Monthly charges can indicate how much customers pay and help with pricing decisions. We extract the monthly charges column as a NumPy array for fast computations. NumPy is used to calculate the mean, average, charge. We calculate the standard deviation to assess price variability. Finding the minimum and maximum helps spot outliers or pricing tiers. Running the cell now. This output summarizes key statistics of the monthly charges column, showing an average charge around $64.76 with a wide spread indicated by a standard deviation of about $30. Noticing the minimum and maximum values helps validate that charges are within an expected range, which is crucial to catch potential data entry errors or outliers. This aligns with the lesson's emphasis on verifying data types and distributions before further market analysis. We want to know if customers who stay longer pay more or less on average. NumPy's CoreCo function computes the correlation coefficient between tenure and charges. The result tells us the direction and strength of this relationship. Running the cell now. This output shows a positive but weak correlation, 0.25, between customer tenure and monthly charges, meaning longer tenured customers tend to have slightly higher charges. Notice the values range between -1 and 1, which quantifies the linear relationship, helping us understand if tenure impacts spending patterns. This confirms the importance of validating numeric data and relationships when analyzing market research, avoiding assumptions without statistical support. Pause and reflect, why might longer tenure be linked to higher or lower charges? Discuss with a peer. Now we calculate the average total charges for churned and non-churned customers. First, we convert the total charges column to numeric format and coerce invalid values into missing values. Next, we create a subset containing total charges for customers who churned. Then, we create another subset for customers who did not churn. We calculate and print the average total charges for churned customers using NumPy non-mean. Finally, we calculate and print the average total charges for non-churned customers. Running the cell now. This output shows the average total charges for customers who churned versus those who stayed, revealing that churned customers tend to have lower total charges. Notice how converting total charges to numeric handles any invalid entries, preventing errors in the calculation. This highlights the importance of data type validation and careful aggregation when analyzing market research data. This comparison helps us understand whether spending patterns differ between churned and loyal customers. You can extend this analysis by comparing other numerical features across customer groups. Binning monthly charges lets the business analyze customers by pricing segment. We define bins of $10 from the minute to the max charge in the dataset. Labels are created for each bin so results are readable. We categorize each customer into a pricing tier using Pandas cut. The counts per bin show which pricing segments are most or least popular. Running the cell now. This output shows how the monthly charges are distributed across evenly spaced $10 intervals, revealing key concentration areas like $20 to $30 and $80 to $90 bins. Notice the zero count in the 0 to 10 range, indicating no customers with extremely low charges, which validates the binning logic. This helps highlight how correctly categorizing continuous numeric data into bins can clarify customer spending patterns for better market analysis. It is important to measure if higher-paying or lower-paying customer segments are more likely to churn. We group the data by charge bin and compute the proportion who churned. This output highlights risk areas in pricing strategy. Running the cell now. This output shows the churn rate calculated for each charge bin, highlighting trends in customer retention relative to their spending. Notice the NaN for the lowest bin, indicating no churn data there, and the peak churn rates in mid to higher charge ranges, suggesting these segments have more customers leaving. This reinforces the lesson's point on the importance of accurate aggregation and interpreting key columns like chargebin and churn to understand customer behavior. Contract type may affect customer loyalty and tenure. We get all unique contract types from the dataset. For each contract type, we filter the data. The mean tenure is calculated for each contract using NumPy. These results inform which contract types lead to higher customer retention. Running the cell now. This output shows the average customer tenure for each contract type, revealing how longer contracts correspond to longer average tenures. Notice the clear increasing trend from month-to-month to 2-year contracts, highlighting the value of correctly grouping and aggregating data by contract type. This confirms the importance of validating categorical data and using appropriate calculations to summarize market data meaningfully. Net Promoter Score (NPS) summarizes customer loyalty from a survey question. We set a seed so results are reproducible. A synthetic dataset is generated with customer IDs and ages. Each customer is assigned a random region. NPS scores are simulated as whole numbers from 0 to 10. Let us preview the first few rows to see the data structure. Running the cell now. This output shows the first 3 rows of a synthetic NPS survey dataset with 500 customers, including their ID, age, region, and NPS score. Notice the NPS_score ranges from 0 to 10, reflecting typical Net Promoter Scores, and the demographic columns help segment responses by age and region. This initial glimpse is crucial for validating data types and ensuring the dataset aligns with survey structure before deeper analysis. The mean NPS tells us general customer loyalty and likelihood to recommend. We use NumPy to find the average of the NPS_score column. Running the cell now. The output shows the average Net Promoter Score (NPS) across all survey responses, calculated as 4.89. This summary highlights the overall customer satisfaction level in the dataset and underscores the importance of correctly handling and aggregating survey scores to accurately reflect market sentiment. Remember, validating data types and ensuring no misclassified scores helps avoid misleading averages like this one. What other central tendencies, like median or mode, might give a different insight for NPS? NPS segments customers into promoters, passives, and detractors for better strategy. Promoters score 9 or 10, we calculate the proportion. Passives are those between 7 and 8 inclusive. Detractors score 6 or less. Percents are printed for each group to help target retention plans. This informs where to focus customer service improvements. Running the cell now. This output reveals the distribution of customers based on their NPS scores, showing a majority, 64.6%, as detractors, which indicates low satisfaction or loyalty. Notice how the code correctly segments the scores into promoters, scores 9 to 10, passives, 7 to 8, and detractors, 0 to 6, helping us understand customer sentiment. This step is crucial for market data analysis to identify key areas for improvement in customer experience. Segmentation by region allows for region-specific marketing strategies. We identify all regions present in the survey. For each region, we extract the relevant NPS scores. We count the number of promoters using NumPy. Detractors are also counted efficiently. We calculate the total respondents in the region. The NPS formula is applied to yield a region-specific score. Each region's NPS is printed for comparison and action. Running the cell now. Notice that the NPS scores for all regions are negative, indicating more detractors than promoters across the board. The code calculates the Net Promoter Score by counting promoters, scores 9 or 10, and detractors, scores 6 or below, per region, then normalizing by total responses, which highlights customer dissatisfaction trends by geography. This reinforces the importance of correctly classifying survey responses and calculating meaningful aggregates in market research data. Try grouping by another variable, such as age group, for more tailored business actions. High-quality insights require full and accurate customer data. We use pandas isnl and sum to check how many missing entries there are in each column. The output helps us decide if we must clean or impute missing information. Running the cell now. This output shows that there are no missing values in any columns of the NPS dataset, which is important for ensuring data quality before analysis. Notice all counts are 0, meaning every record has complete information across demographics and survey scores. This validation step helps prevent errors in interpreting customer satisfaction trends or segmentation later in the lesson. Incomplete survey responses are a common issue in market research. We create a copy and make the first 5 NPS_score values missing. The np.mean function attempts to compute the average with these missing values. If NumPy cannot handle the missing values, it raises an error or returns nan. The output helps you understand the importance of handling missing data explicitly. This step prepares you for practical business scenarios with imperfect data. Running the cell now. This output shows that even with missing values introduced in the NPS_score column, the mean calculation still returns a valid number, about 4.9. This highlights that functions like np.mean by default ignore nan values, preventing errors but also potentially skewing analysis if missing data isn't handled consciously. The lesson here is to be aware of how missing survey responses affect summary statistics and to explicitly manage or impute them when needed. One way to handle missing survey responses is to replace them with the mean score. We copy the modified data frame with missing values. The np.nanmean function computes the mean while ignoring nan values. Missing NPS_score values are filled with this mean. We print the first few values to show the change. Running the cell now. This output shows the first 6 values of the NPS_score column after filling missing data with the column's mean score, 4.90303. Notice how all previously missing values are replaced by this average, maintaining data consistency for analysis. This step is crucial for preventing errors and bias in market research metrics when handling incomplete survey responses. If you want to master missing value techniques, search Pandas data cleaning on YouTube. Business decisions can go wrong if analysts use the wrong aggregation method. Sales numbers are provided with a missing value. Using mean instead of sum gives the wrong total. np.nansum provides the correct total by ignoring missing values. Always double-check which aggregation matches the business question. If an error occurs, it is shown for easy debugging. Running the cell now. This output highlights a common pitfall in handling market data, using the mean instead of summing sales figures, especially when the dataset contains missing values, nan. Notice that taking the mean results in nan due to the presence of a missing value, while using np.nansum correctly ignores nans and returns the total sales of 110. This underscores the importance of choosing the right aggregation function and properly handling missing data to get accurate insights from sales data. Segmentation is a foundational tool in customer analytics to target specific groups. We define bins for tenure, representing the number of years with the company. Each bin is given a label for easy interpretation. We assign each customer to a tenure group using Pandas cut. This breakdown helps marketers tailor retention offers or messages. Running the cell now. This output shows the distribution of customers segmented into tenure groups, helping us understand how many customers fall into each tenure range. Notice the highest count is in the 1Y group, indicating many recent customers, while the counts generally decrease as tenure increases, except a slight rise at a 5Y+. This validates the correct use of PD cut for grouping continuous tenure data into meaningful categories, a key step in analyzing market research data by customer lifecycle segments. Cross-tabulation shows the churn rate for each tenure group. We use Pandas crosstab to create a table of tenure group by churn status. Normalization by index converts counts to percentages within each group. Running the cell now. This crosstab shows the proportion of customers who churn or stay within each tenure group, highlighting that longer tenured customers tend to remain more loyal. Notice how the churn rate steadily decreases as tenure increases, illustrating an important trend in customer retention analysis. This reinforces the lesson's point on correctly grouping and validating survey data to reveal meaningful market insights. Customer Retention Index (CRIA) measures how well the business keeps customers. We create a binary column, 1 if retained, 0 if churned. Group by tenure and calculate the mean retention rate. Results are multiplied by 100 and rounded for reporting. These metrics support management in evaluating loyalty by group. A high CRI in longer tenure groups may indicate effective customer engagement. Running the cell now. This output shows the Customer Retention Index (CRI) as a percentage across different tenure groups, highlighting how retention improves with longer customer tenure. Notice the clear upward trend, from about 52% retention for customers under 1 year to over 91% for those with 5+ years, demonstrating how grouping and correct Boolean to integer conversion enable meaningful aggregation of churn data. This reinforces the lesson's emphasis on validating data types and properly handling categorical values for accurate market insights. Try visualizing this result with a bar chart to instantly spot trends. Trend analysis can uncover seasonality in customer satisfaction. We randomly assign a month to each NPS record for illustration, normally use real dates. Group by month and calculate the average NPS score. Monthly averages are printed to evaluate peaks and dips in customer sentiment. Business leaders use these trends to launch campaigns or investigate declines. Running the cell now. This output shows the average Net Promoter Score, NPS, calculated for each month, highlighting how customer satisfaction trends can vary over time. Notice the grouping by this month column and the mean aggregation of NPS_score, which helps identify seasonal patterns or shifts in customer sentiment. This step is crucial for validating data transformations and ensuring you interpret survey scores within the correct temporal context. What external events might explain a spike or drop in a given month? Discuss with your team. In a real business scenario, you want to find which customer group is most at risk. We group by tenure and calculate churn rates. The churn rate by segment is printed, highlighting risky areas. We identify which segment has the highest churn rate. The output recommends an immediate action for the segment needing most attention. Running the cell now. This output shows the churn rate calculated for each customer tenure group, revealing that those with less than 1 year are most likely to churn. Notice how the churn rate decreases as tenure increases, highlighting a key trend in customer retention. This validates our code's intent to identify the highest risk segment for targeted retention efforts based on market survey data. You have completed a practical end-to-end market research analysis with NumPy.